Assalamu alaikum guys, I hope you are doing well. So in this video I want to discuss about TLS, known as the Transport Layer Security. So this protocol is widely very common with web security. So you might have used websites, browsing website, and you might have seen a padlock icon on the website on your browser. So this padlock icon basically signifies that this website, the data that is being transferred between your browser and the website is encrypted or secured using this very same protocol, transport layer security, TLS. So as we know that we use browsing websites, so the web applications, they all work over HTTP or hypertext transfer protocol, which in itself is a insecure protocol, meaning the data that is being transferred using the HTTP, um, anyone in the man in the middle attack, if anyone who would eavesdrop on the packet, they can easily see what's the communication going on, what's the data that is being transferred between client and server. But having the HTTPS, the security that comes with the TLS, this protocol on top of your HTTP, now what happens is that the data that's being transferred between your browser and the server is getting encrypted. And now if anyone's able to eavesdrop on that communication, they will not be able to know what the communication is going on because everything is encrypted. So in this video we are going to focus on this layer, this transport layer security, this protocol. How does this thing happen? So the process is to imagine that your browser is the client and the server, let's say google.com, is the server that you're trying to access. So this is what happens. So first of all, the TLS client, your browser, sends a client hello to the server saying what are the TLS protocols. So since within TLS there are various protocols like 1.2, 1.3, so which version of the TLS protocol your browser supports, and what are the CyberShahLive, meaning the symmetric and asymmetric algorithm that your browser supports. It sends that information to the server. The server the server then responds back with the certificate, the digital certificate that is issued to that particular server from the certification authority, CA, and then using the CA digital certificate that it contains, it has the public key of the servers. So now what now what client does, it basically first verifies the digital certificate, whether the digital certificate is authentic or not, whether it is trusting that the CA who has basically signed that certificate. Okay, so once it is verified, the digital certificate, it then uses the public key of the server and then encrypts the key with it and then send it to the server back. And now what happens is the key that was sent using the public key, the server is going to decrypt it using its private key, and so now both the client and the server have the secret key, um, and then they gonna use that key for encrypting and decrypting the follow-up communication that happens between the clients and servers. So this is how the TLS works on a high level. So let's try to understand. So first of all, the process is called TLS handshake. So the TLS handshake basically establishes authentication connection between a client device and the servers. So here is how the TLS handshake works. So first, the client device sends an initial message, client hello, to the destination server. It includes the version of TLS it supports as well as the cryptographic algorithm it supports, commonly known as the CyberShahLive. The server responds with the server hello message that includes its certificate, which is public key. the client device verify this TLS certificate, and the client device then create a pre-master secret key that encrypted using the public key. Now the server decrypts the pre-master secret key with its own private key, and both the client and device servers now have a process that been completed, and now they can use a symmetric key going forward to use for encryption and decryption, whatever the communication that happens afterwards. So this is how basically the TLS process works. Now let's try to understand a little bit much deeper. So when a browser connects to the secure website HTTPS, the server presents its certificate verification. So the browser verifies the digital certificate through certification authorities, check the certificate expiry date, signature, and whether it has been revoked or not. Then we have a session key creation. So the browser generates a symmetric session key. If the certificate is valid, it encrypts the key with the server's public key and then send it back to the server. And the server decrypts the session key using the private key. Both the server and browser now have the shared symmetric key, which can be used for the duration of the sessions, and a safe connection established with all the transmitted data encrypted using the symmetric key. So this is how the process looks like. So you have the client, and then you have the servers, which is sharing the certificate, and then it is how the process is finished. Now notice this, the TLS 1.3 and TLS 1.2, we have a little difference in here. So here in the TLS 1.3 we do not have a round trip. All the process happens in one single round, whereas in TLS 1.2 we have a two round trip. So for the client's hello and then server hello and key exchange, and then the client key exchange happens, change of cyber in a specification happen, and then so there is a two-way round way trip which is not happening in TLS 1.3. Okay, so this is the difference between TLS 1.2 and TLS 1.3. So it requires two round process in TLS 1.2, and in TLS 1.3 it has only one round trip. Okay, performance wise, if we look into TLS 1.2 is slightly slower due to multiple rounds, and TLS 1.3 is faster due to the reduced round trip. In terms of security, TLS 1.2 is slightly less secure because it uses various older cryptographic algorithm, whereas TLS 1.3 uses modern, more secure cryptographic algorithms. Coming to the cyber suits, so in TLS 1.2 we have a mix of secure as well as less secure cipher suits, whereas in TLS 1.3 we only includes more secure cipher suits. Okay, so this is are the major difference between TLS 1.2 and 1.3. So let's dive into a little bit into the certification authority. How does the CA things work? So when you visit a website, the server sends a TLS certificates to your browsers, and then you have to trust the certificate authority who has. So your browser comes with a list of all the root CA, and basically it's used for identification purpose whether the certificate is really signed by the verified by the right CA authority or not, and that's how the process happens, which we already discussed in previous slides. So yeah, that's how the process of TLS is, how TLS works. So thank you for watching, and I will see you guys in another video. Until next time, Assalamu alaikum.